Welcome to another tutorial on MATLAB. In this series, we are looking into the plant modeling and the concept of plant modeling implementation in MATLAB. This will help you to build different type of system equations and system models in MATLAB. So in the last tutorial, we have seen how to design the system equation for a suspension system. In this tutorial, we will see how to implement the same equation, the same system equation into the Simlink environment. So let's get started with the same. First, we need to type Simlink. This will open the Simlink canvas. So this is the blank model which we need to select here. So we need to first add the integrator block, as the system is of second order. So we need two integrator blocks, and we need to connect these two integrator blocks. Next, we need some add block. So this will do the arithmetic operation between the component of the equation. So as we have three arithmetic operations, we need to define that. So first is the plus and then 2 minus, and press on OK. Now we need to take a gain block where we will be defining all these gains. So let's define the gains. So C by M is one gain, which is related to the velocity of the mass. Next, we need to duplicate and create the second gain, which is related to displacement, which is K by M. Again, we need to duplicate the same and define 1 by M, defining 1 by M for the applied force. Now, as we already know, the system equation is this one, where we need to implement the system equation. So let's implement this. We need to connect all these blocks properly. So we can connect the velocity part with C by M, and this is the X dot or single dot. Next, we need to connect the acceleration to the input to the integrator. Here the signal is X double dot, which is acceleration. Next, we need to connect the displacement part. Here it is X, and we can connect this one to the add block directly now. So we will be connecting the velocity and the displacement part now to the add block. Now the remaining part is the force. So for this, we need an input. So if we see the equation, then here mg also is the input and the applied force is also the input in the same direction. So for this, we need to do the addition of both of them. Here the input force will come from outside and it will be added with the mass into gravitational acceleration. So we need to define mass as constant. So we need to add a constant block. Here we need to give the mass, which is M. Then we need to duplicate this gain block, and then we need to assign it a value of G. So here G is the gravitational constant, and we can connect these two and connect to the final gain. Now we need a go to and from block system to transfer the signal values from the gain output to the add input. So this is the output from which you will be able to connect to the add block. So now the system model is almost complete. Now we need to select which are the signals that we want as the output. So for this, now let's select every entire area and make this part as the subsystem. So this will decide like how much force if we apply, then how much input it will give inside the add block. So this is the force calculation subsystem. Now we will give a color, background color maybe yellow, and we will also give some format background color to this one as red, as this one also red, just to do the color coding. Now let's add some scope to this particular model to measure the relevant signals. So here we have defined the input ports as 4 as we will be measuring 4 signals. One is the applied force, and the 3 are the outputs, which are acceleration, displacement, and velocity. So A we are defining for acceleration, and D for displacement, and V for velocity. So this is for displacement. We will connect this to the displacement signal, which is X, and then we will be connecting to the velocity. Here we need to name it as V. Again, we need to do the same for acceleration. So this we can name as A. Now we can drag. Now we can connect the input force, where F is the force, which we will be giving to the scope. Now let's drag the from blocks from individual blocks and connect it to the scope. So before this, we can format all these blocks. This will make the job easier. We do not need to do it for the from block if we do it for the go to block. So let's define the colors for individual go to and from. For force, it is blue. For acceleration, we can go to background and decide canny. For velocity, we can go to format background, and here we can select green. For velocity, it is green. And for displacement, we can choose yellow. So now let's drag these blocks to the from block. So every from block will have their corresponding colors. So this is how you can color code your model with a proper format. So here green is representing velocity, yellow is representing the displacement, and blue representing the force, and canny representing the acceleration. Now we need to format this scope. So we need to select open at simulation, and also we need to select the layout. So we need 4 signals to be present, and also maybe we need to name the signals like acceleration, velocity, displacement, and force. So let's name them. So applied force is the last one. Now let's simulate this model, but before this we need to define what is G. Remaining things are already defined, but G is not defined. G is 9.8. Now let's see, all the variables are already defined now. Now let's go to the model and select this entire thing to make it as a subsystem. So this subsystem has one more subsystem that is inside it for force calculation. Along with that, this itself is a subsystem, which is the first level subsystem. The other one that is there inside this subsystem, the other subsystem, is the second level subsystem. So let's connect some input force like we applied last time by manual switch. So we will have a switch, and then we need to connect a sine wave where F is the magnitude of the force, which is small f, and again we need to add a step block which will apply the step signal, and this will also have the magnitude of f, the final value. Now let's simulate this model and see how this output looks like. So this is the output of this model. Again, if we switch this input, again if we simulate, then we will get the other output. So the down one represents the force, and the upper one represents the acceleration, then velocity, then displacement. Now as you can see, the displacement is gradually rising and acceleration suddenly raised because of the applied force. Now let's increase the simulation time and play it. So here we are getting the plots not in a proper way. So there is a technique in MATLAB in which you can make this proper. So you need to go to the model setting, and here you need to choose fixed type solver, and in the fixed type solver you need to set the sample time. Sample time should be 0.001. This will solve the model very frequently to get the output smooth. So now you can see the output is getting smooth, and in case you are not getting your outputs in a smoother format, then you can just change the solver setting and reduce the sample time, then it will give you a smooth output. So this is how you can create a Simlink model for a mass damper system or a suspension system. Those are two mechanical systems, and by deriving the system equation, you can create the system equations plus the subsystem, which will just replicate the behavior of a mass damper system or a mechanical system. It could be a electrical system as well. So this is how you can implement all these things and create the plant model. It do not depends on any domain. That is the main advantage of this. So if you have system understanding, then you can create system equations, and from that you can create Simlink models. So even if you do not have the domain knowledge, if you have the system equations, anyhow it is mathematics, so that can be implemented in any way, and you can implement the Simlink model in the proper systematic way. In this case, you do not need any toolbox, and you can also change very minute system properties by changing the mathematical aspect of the system equation, like selecting different mass as a parameter, or spring constant, or damping constant. In case you are liking our channel, please consider subscribing. In case you have any comment or any suggestion, please share it with us in the comment section. So happy learning MATLAB and stay connected.